Hello everyone, welcome back to In today's video, we are diving into process states, process transition diagrams, and schedulers, key concepts in operating system. So, by the end of this video, you will understand what process states are and why they matter, the process transition diagram, and how process move between states, then the role of schedulers in managing process execution. So, without wasting any more of your time, let us get started. Firstly, what is a process? A process is simply a program in execution. A process is simply a program in execution. Whenever you open a web browser, start a game, or play a video, your computer treats them as process. Each process has its own code, memory, and resource allocated by the OS. But processes do not just stay in one place. They transition through different states. And what are those states? Those are process states. A process doesn't run instantly. It moves through different states, just like a student moves from study, waiting for result, and then graduation. So we have five main process states. The first one is new. The process is just created but hasn't started yet. Example, when you click on an app, it enters the new state before running. Okay, it means that you have just created the app, then that is the new states. Then we have the ready state. It means it is waiting for the CPU to execute. The process is loaded into the memory and waiting for the CPU to execute it. For example, if you have multiple apps open and the OS decides which one runs next, then we have the running next at third position. It means that executing on the CPU. It is currently executing. The process is actively using the CPU to execute its instructions. An example, when a video plays smoothly, it is in the running state. That video you watch on YouTube, it is in the running state. Then we have blocked state. But why blocked state? The process pauses because it's waiting for an input or output. For example, a printer job is in blocked state until the printer is ready. Because you have not, if you have not connected to the printer to the computer, it will be in a blocked state if you have something to print. Then we have the last terminate step. As the name suggests, the process is terminated at this state. The process finishes execution or it is forcefully stopped. Example, when you close an application, it enters the transition state. For example, if you see into this PPT, if I close this PPT, it will enter into termination state. Then we have process transition diagram. But what is a process transition diagram? Now, let us look at how process move between these states. This is called the process transition diagram. We had five states, but how they do move between them. Firstly, there is the key transitions are new to ready. In the new to ready state, the process is created and loaded into the memory. Then we have ready to running. The scheduler picks a process to execute. After that, we have running to blocked. If a process needs IO, it moves to blocked or is waiting for a certain resource, but the resource is preoccupied. Then we have block to ready. If it means the once the IO is complete, it returns to ready. If it has got the resource it needs to execute, it returns the ready state. Then we have running to terminate. It means that the process completes or is stopped by the operating system. After that, we have the running to ready. If a higher priority process arrives, the CPU switches tasks. This we learned in the previous lecture in the scheduling algorithms. Now, let me give you an example so you can understand process transition diagram in a better way. Firstly, imagine you are a chef in a restaurant. Okay, so an order comes in. That order is a new state. Then the chef decides which order to prepare. The decision, the chef is the CPU, and the order to prepare, it means that it is ready to running state. But what if an ingredient is missing or cooking pauses? ठीक है? The same thing happens in the operating system. If an resource is not available, it gets into the block, running to blocked state. But once it's available, the cooking resumes. Cooking resumes means block 2 ready. Finally, the dish is served. That is running to terminated. This is an example which justifies all the process transition diagram in a clear and concise way. Then we have schedulers. Schedulers in operating system. So, how does the OS decides which process gets the CPU? That's where schedulers come in. Schedulers, it means someone which schedules the process. Okay, scheduler manage the process and ensure efficient execution. So, we have four types of schedulers in operating system that we study. The first one is long-term scheduler. It means job scheduler. It decides which process enters the ready queue. It runs infrequently but controls overall system load. For example, deciding which app can run in memory. What do you understand by this? It means that the long-term scheduler runs very sometime, but it manages the overall system load. So it is important, but it is not able to run more frequently. Then we have the short-term scheduler or CPU scheduler. It selects which ready process gets CPU time. Then it runs very frequently because it has to serve the each and every process. So it runs every few milliseconds, not even seconds, milliseconds. For example, switching between a music player and a browser, the amount of time that we need in that process is negligible, but that is done by the CPU scheduler or short-term scheduler in few milliseconds. Then we have the middle term scheduler, not the long, not the short, but the middle term scheduler or swapper. It temporarily removes some process from the memory to reduce load. For example, if you are playing a game, it might cut all the RAM that is used. So we have to minimize the game to free up some RAM. It helps in multitasking by bringing back paused task when the memory is free. So if you are playing a game and there was some task which was paused because of the game, then if you have minimized the game, it will free up the RAM and that task will execute. Okay, and so now think of all these schedulers like a school. The long-term scheduler decides which students are admitted. That is the principal. The short-term scheduler selects who gets to speak in class. It is the class teacher. Then we have the medium-term scheduler. It decides who takes a break to reduce overcrowding. Who is this? It is the monitor. Okay, so think of it like this: the long term scheduler is the principal, short term scheduler is the teacher, and the medium term scheduler is the class monitor. So, let us conclude what we have learned in today's lecture. Firstly, we learned about process states: new, ready, running, blocked, and terminated. Terminated or terminate. These are the five states of a process. Then we learned about process transition diagram. It means the how the process moves between all the five states and when a program is in execution. Then we also learned about schedulers, long-term scheduler, short-term scheduler, and medium-term schedulers. These all the schedulers play a vital role in keeping your system fast and responsive. After that, now I want you all to comment in the comment box an example of scheduler, another example of scheduler. So hope you like this video. If you like this video, please comment and subscribe and like too. Thank you. See you in the next lecture.